Alright, you are welcome back to Introductory Mathematical Analysis A, and we are still in chapter 8. But this time around we are going to be going to chapter 8.5. Chapter 8.5. Okay? In chapter 8.5, we have conditional probability and stochastic processes. That is the topic of chapter 8.5, conditional probability and stochastic processes. Okay, conditional probability, if E and F are events associated with an equiprobable sample space and F is not empty. Okay, F must not be empty. Then we have this formula. Okay, so the probability of E given F. Okay, so when we have this is E given F. F is already given, or F has already occurred, or F has already happened. The probability we are looking for is the probability of E, but F has already been given. Then we have the formula, the number of E intercept F over the number of F. Okay, so that is when we are finding the probability of E given F. But I will write another way now. Probability of F given E. Then this will be the number of F intercept E. Okay, F intercept E over the number of E. Okay, that will be if it is F given E. But take note that these intercept and these are the same. Either you say E intercept F or you say F intercept E, they are the same. They will get the same answer. They will get the same number. Okay, so please take note. What you are going to be finding in probability, in this conditional probability, or the first challenge you are going to come across is to determine if you are finding E given F or you are finding F given E. You must know what you are giving first. You must be able to get out what are you giving. Okay, please take note of that. All right, so let's go with this one now. So now we see a bag contain 2 jelly beans, say B1 and B2, and 2 blue jelly beans and 2 white jelly beans, W1, W2. If 2 jelly beans are randomly taken from the bag without replacement, take note of that, without replacement, find the probability that the second jelly bean taken is white, given that the first is blue. So if we are taking the first to be blue, given that the first is blue, okay, let's take blue, that is the first one. The second one, we want it to be white. Okay, so that means the second one could be W1. Again, W2. Okay, I'm just taking the first one to be blue, W1, W2. Okay, but you can also have in addition that when we take the first one to be blue 1, the second one could be blue 2. The first one to be blue 2, the second one to be blue 1. So all these ones as blue as the first one. We need that given. Okay, you see, blue is the first one for all of them. Blue is the first one for all of them. Don't mind this other one, blue first, blue second. It's important we include it. But we are looking for blue as the first one for all of them. Okay, so now let's look at this now. So probability of white giving blue. Probability of white giving blue. So we need to find how many is the intercept of white and blue. And then how many is the number of blue. Okay. That is it. This one just mean the total one. So now this is how many is the intersects of white and blue, which is this 1, 2, 3, 4. Okay, so that will be 4 over the total, which is 6. All right. So we're going to be having then 4 over 6 or 2 over 3. Yeah. Please take note of that. Make sure that you take note of that. Okay. All right, that is what we have done. That is just what we have done. That's what we have done. All right, so the conditional probability, recall before that we said that E given F, we can use number to find it. We can use number to find it. We count the number of intercept over the number of F. But sometimes you don't have the number, you have the probability. So if you don't have the number, you use this. So you either use this one or you use this one, depending on what you have. Now this is the probability, using probability and not the number. And of course, probability of F must not be 0. That's why the number of F must not be empty also. The other hand must not be 0. Must not be 0. Either you say the number of F must not be 0 or F must not be empty. The number of F must not be 0 or F must not be empty. Okay, so you can either use this one if you have the number to count, the number of in the set, the element there, or you have the probability, you use this one. Okay, any one of the two can be used depending on what you have or what you are given. All right, so let's take this example. After initial production run of a new style of steel deck, a quality control technician found that 40% of the decks had an alignment problem. Okay, 40% had an alignment problem. All right, 10% had both defective paint job and alignment problem. 10%. If a deck is randomly selected from this run and it has an alignment problem, what is the probability that it has a defective paint problem? Okay, the first thing whenever you are given such problem like this is to identify two things they are talking about. Number one, alignment problem, and then number two, paint job problem. Okay, defective paint job problem. So if I call this alignment problem A and I call this paint job problem D, okay, so I say A for alignment problem, A for alignment problem, and D for defective paint job problem, defective paint job problem. Okay, now what are we given? Read the question again. If a deck is randomly selected from this run and it has an alignment problem, so we are given alignment problem already. So what we are looking for is D given A. Please take note of that. That is very important to know which one is given. Read the question again. It has an alignment problem. What is the probability that it has a defective problem? So we are looking for the probability of a defective paint job problem while we are given an alignment problem. So if you want to write this now, you now say D given A. So the probability will now become, you need to know how to write this first. Please, you need to know how to write that. You have probability of D intersect A all over probability of A. Okay, all right. If you write it this way, then you'll be missing a lot of things. So please know what is given. You are not given D, you are given A. Please know what you are given so that you can now know how to write your conditional probability. Okay, so that is it. So as soon as you are able to pick that, then you know this intercept is for this 10% because 10% are both defective and this one is for this one. Okay, so that is fine. That is all. That is all to get. So our probability of A is that 40% that we have. This is it. And this is for the 10%. And then we just use the formula to get our answer. Okay, please take note. What to take note is to take note, what are we giving? You may not be told every time giving this, but you must read and say and identify what we are giving. Here we are giving that it has an alignment problem already, an alignment problem. So that is what we are giving. So please take note of what you are giving so that you can write your probability correctly. Okay. All right. I did mention to you that, okay, if we have probability of E given F is equals to probability of E intercept F, okay, or all over probability of F. And then if we have also probability of F given E, this you can write as probability of F intercept E all over probability of E. Okay, and I did mention that this intercept and this one, they are the same. Either you write E intercept F or you write F intercept E is the same. Okay, but for clarity, it is always good to write alphabetically. So if I want to write alphabetically, I will change this. If I want to write alphabetically, this will be changed to E intercept F. You see, it's now just the same. Alright, so I can make this the subject of the formula here. I can make this the subject of the formula here. So it implies F intercept this is equals to probability of E given F, probability of E given F, probability of E given S multiplied by probability of F. Okay, for that one. This one also implies that probability of E given of E intercept F equals to probability of F given E multiplied by probability of E. So you see now, since this and this, they are the same, I can equate these two together. I can equate these two, and that's what we have done here. So we can equate the two together, and then we get this. So sometimes you need these two ones, probability of E multiplied by probability of F given E equals probability of F multiplied by probability of E given F. So sometimes you need this formula to solve your problem. Sometimes you need this other formula to solve problem. Alright, so please take note of that. Okay. Alright, so let's use that now. A computer hardware company placed an ad for its new modem in a popular computer magazine. The company believes that the ad will be read by 32% of the magazine's reader. Okay, 32% will be read. So if we say read, that is for those who read, donate as R, and that 2% of those who read the advert will buy the modem. Okay, so we have another thing called buy. So we have those who read, we have those who buy. Alright, so 2% of those who read the ad will buy the modem. Okay, assume that this is true and find the probability that a reader of the magazine will read the ad and buy the modem. So what are we looking for here? We are looking for and. This is and. Read and buy. So we are looking for R intercept B. So that is read and buy. Find the probability that a reader of the magazine will read the ad and buy the modem. Okay, that is fine. But which one should we use? This is very important now. Take note. Which one should we use? R given B or B given R? Okay, let's read and see which one is given to us. See, the company believe that the ad will be read by this. So this is read. So we are giving probability alone of read. Okay, probability alone of read. So and then that 2% of those who read the album will buy the modem. So we are giving, so if you write this formula, this one is same thing as probability of read intercept B over probability of B. But this one is the same thing as probability of read intercept B over probability of read. You can see now from the two formula, this is the one you are supposed to use. So this is the one you are, because we are given this already. This one is what we are looking for. This one is also given, which is the probability of those who read the ad will buy. That's the probability of buy giving read. This is the probability of buy giving read. So we use this formula. So we are supposed to use this formula. We cancel this one. We are supposed to use that formula. Probability of B given R is equal to probability of R intercept D over probability of R. But we are looking for this one. It is the intercept we are looking for. So that is probability of R intercept D. That implies equals to probability of B given R multiplied by probability of R. Okay, that is it. And then we bring our percentage to come. Probability of that is 2%. 2% multiplied by 32%. Okay, which is 0.02 multiplied by 0.32. And then we get our answer. Okay, that is it. And then we get our answer. Please ensure that you understand what we're doing there. All right, so let's take this example now. Two cards are drawn without replacement from a standard deck of cards. Find the probability that both cards are read. Okay, don't forget again, standard deck of cards. You need to know what is it. Okay, so in a standard deck, don't forget we have 52. Out of this 52, we have 4 suits. Each of these 4 suits is made up of 13 types. Okay, 13 types. But from these 52 also we have 26 red and 26 black. Okay, 26 red and 26 black. So if the probability of choosing the first red will be 26 over 52. Don't forget that. But it's without replacement. So the probability of choosing the second red given the first red will now be, don't forget, is now the second one now. So 25 over 51, then multiply by 26 over 52, which is this one. Okay, that is the probability of choosing, which is choosing, find the probability that both are red. So that's the probability of both are red. Okay, that's probably, but this one's supposed to be this one. Why? The probability of both are red is just the multiplication of these two. Yeah, it's just the multiplication of that two. It's just multiplication of that two. Okay, please ensure that you understand. All right, thank you.